All right, in this last section of polynomials, what we're looking to do is actually work backwards from the roots or solutions to the polynomial that could produce them. There are a few keys to this, and the first is going to be like you shouldn't have in your answer roots, fractions, or imaginary numbers. They should all be whole integers, working out pretty much perfectly. Which is going to get us to, well, what if we have a root that does have a square root or an imaginary number in it? Well, then what should happen? And that gets us to what's called the conjugate root theorem, which is this right here. If we have an irrational number or a complex number as a root, then its conjugate is also a root. And just to remember what conjugates are, like if I had 4i, its conjugate is negative 4i. And if I have negative root 7, its conjugate is positive root 7. And they could be even more complicated. If I had 2 plus I, its conjugate is 2 minus I. Notice that the sign in between is opposite. And if I had 4, say, plus root 5, then that conjugate is 4 minus root 5. And likewise, if I started with a minus, say I had 3 minus root 2, then the conjugate of that is 3 plus root 2. Again, notice the signs are opposite. So those are conjugates, just as a quick rehash, and that gets us to how we would write a polynomial with key integer coefficients. So again, if you get square roots or i's into your final answer, you have made a mistake. So I have been given these two roots, which means that if I were to graph the polynomial, I have a root at 4 and a root at root 5, which is somewhere over here. And then because of the conjugate root theorem, I also will have a root at negative root 5, so somewhere over here. So I may have a polynomial that looks like this. Now, given these roots, I don't know exactly what I started with, but I can write like the simplest possible polynomial from this information. So the first thing I'm going to do is unsolve this. So I'll subtract 4, and I get x minus 4 as my first factor. And then right here, I have x equals root 5, so I unsolve that. That's a 5. I subtract root 5, and I get x minus root 5. And then finally, I have x equals negative root 5. I unsolve that. I'll add the root 5, and I have x plus root 5. Now, at this step, I'm basically there. Now, that's not in standard form. This is called factored form. I want to get this down to what's called standard form, which is generally how we write a polynomial. And in order to get it down to standard form, I'm going to have to do the keyword expand. And expand simply means I'm going to multiply all this out. And it can be very tricky because if I start with multiplying this x minus 4 into this, I'm going to get a mess. I'm going to get a mess anyway, but that will make it worse. I want to multiply the conjugates first, so I'm going to multiply these two things first. So x times x is x squared, and x times this is plus root 5x. And then I have the negative root 5 times x. Notice I'm going to line it up right here with the one I already did, minus root 5x. And then finally, root 5 times root 5. Now, you may not know this. Root 5 times root 5, if these both have the same index, that is, they're both square roots, I can go ahead and multiply those two things in there. And 5 times 5 is 25. And the square root of 25 is simply 5. So minus 5. Now I'm going to combine all these like terms, and I notice that these cancel. So I have x squared minus 5, and then I'll copy this x minus 4 down. And now I'll continue multiplying. Now I'm ready to bring the x minus 4 in. This distributes to each of these. So I get x cubed, x times x squared, minus 5x, and now I'll do the negative 4. Negative 4 times both of these is minus 4x squared plus 20. I'll now put everything in order. So x cubed minus 4x squared minus 5x plus 20. And that is the standard form. So that's the solution. That is the polynomial, the simplest polynomial I could write that has these as the roots. Okay, I'm actually not going to, so that was example 1. I'm not going to do this one. It looks kind of incomplete-ish. I will do this as example 2. And notice, key idea is the same. I want to write the polynomial. Now, I have a root here and another root, so this is going to be quite long. So I have x equals 2 minus root 3. And since I have that, I also have 2 plus root 3. This isn't fully writing. And then I have x equals root 2, well, the conjugate of that is negative root 2. Now I unsolve all of these. So unsolve this, x minus root 2. Unsolve this, x plus root 2. See, I'm like adding that back over. And then right here, now actually the biggest mistake actually isn't the multiplying. Generally, we're going to get that right. But what is the biggest mistake that I see students do is just forget about this x. For whatever reason, we just get in a hurry and we write this. And there's a problem. This x just doesn't go away. And also this 2 should be subtracting over there. So I need a minus. Now, if I multiply all of this together, that's going to give me what I'm looking for. And this is the factored form. Now I'm going to go ahead and get the standard form, which means I'm going to multiply out. I'll start with this one on the right. X times x, x squared. X times this, plus root 2x. Negative 2 times x, so negative root 2x. Notice how I'm just lining these up. And then that's going to be negative root 2 times root 2 is negative root 4, which is negative 2. So minus 2. And I'll just write that down, x squared, and then minus 2. Now I'll do this one. This one is pretty terrible. X times x, x squared. X times that, minus 2x. Then x times that, minus root 3x. Now I'll do the negative 2. Remember, take the negative with it. Negative 2 times x. Now notice I'm going to write it under the this right here because I'm lining up my like terms. And then negative 2 times negative 2. Now I don't have a like term for that, so I'll just put it over here. And then negative 2 times that. Again, negative times a negative is a positive, but plus 2 root 3. And I'm just leaving myself space to fill in. Now I'm going to do root 3. Root 3 times x. That's root 3x. And see, I'm going to put it right here with this root 3 so that I can see that those cancel. Then root 3 times that, negative 2 root 3. See, I'm just filling it in. See, those line up. And then root 3 times negative root 3, that is going to be minus 3. See, I lined it up my like terms. Now I can just add down, and I have x squared minus 4x. Those cancel. Those cancel. Then minus 1. Now, some students like to just write it all in one big line, and that's okay. I just find that kind of even messier than this. Now I'm going to continue multiplying. X squared times that, x to the 4th, x squared times that, minus 2x squared. This, negative 4 times that, negative 4x cubed. This times this, plus 8x. This times this, minus x squared. And then finally, plus 2. And I'm going to do all the like terms and write it in order. There isn't anything like this. I have that, so copy that down. Notice I'm putting it in order, x to the fourth, x cubed. Now, I have this and this, so minus 3x squared, because negative 2 minus 1, and then plus 8x, and then plus 2, and there's my answer. That is the standard form. Now, really, at this point, you have enough that you could do your homework, you're set to go, but let's go through a few more examples. So this will be example 3. And now I have an I, and I have a 3, negative 5, or a positive 5i, and since I have 5i, I also have negative 5i. Now, another common mistake is to misapply the conjugate root theorem. 3 does not have a conjugate. There's no square root, there's no I, so there's no conjugate. Okay, so I unsolve each of these. So I have x minus 3. This will be x minus 5i. And this will be x plus 5i. And again, this is the factored form. To get it into standard form, I multiply. I'm not going to start with this x minus 3. I'm going to start with this. So I'll have x minus 3, x times x, x squared, x times this, plus 5ix, 5i times x, minus 5ix, and right here, negative 25 I times I is I squared. Now I did write it all out in a long thing this time. It's fine. I squared. Remember, I squared is negative 1. So this is not negative 25. It is positive 25. And I see that these two things cancel out. At this step, I continue. X times x squared. That's x cubed. X times that plus 25x. Negative 3 now. And negative 75. Now I'll put everything in order. And I'm done. That's the standard form. This polynomial has these roots. So before, we would start with this polynomial and get these roots. Now we're starting with the roots, getting the polynomial. For example 4, I'm not going to multiply it out. I don't think it's really beneficial to keep it takes a long time, and you really just need to practice it yourself. But let's at least get it set up. So I have two things here. This one has a root 7. This one has an I. So I have x equals 2 plus I, which means I also have, due to the conjugate root theorem, 2 minus I. And then right here, I have x equals 3 minus root 7, which means I also have 3 plus root 7. Now I unsolve all of these, and remember, you need to have the x. It does not disappear. Minus 2, minus I. X minus 2 plus I. I have the x. X. Subtract the 3, add the 7. So minus 3 plus root 7. Then we have x. Subtract the 3 minus root 7. And then, if we were going to multiply it out, we would multiply these first and these, and then multiply those two answers together. And it would take a really long time and not really worth it right now. Okay. Example 5. Again, I'm just going to set it up. I won't do the multiplication. Notice there is no i's. There is no roots. Therefore, the conjugate root theorem doesn't apply. So I have x equals 3, x equals negative 1, x equals 4, and I just unsolve those. And this is the factored form, by the way. If the directions say to write it in standard form, you would multiply it out. Actually, let's go ahead and do it. Why not? So I'll multiply these. Copy that one down. Not going to do anything with it yet. Simplify this. Now I'll multiply this and this, so x squared times that. -2 now. Remember to take the sign with it, so -2 times -4. And then -3 times that there. And then plus 12. Combine like terms. And there we go. This is the standard form. All right, this one, let's skip that one. I don't feel like it. But I do want to make up an example, I suppose. So let's say I had x equals, let's say 2/3, and let's say x equals -5/2. This one doesn't have any conjugate roots, but it is tricky because we're not allowed to have fractional things in our answer. So remember how we did divide and slide? So I'm going to unsolve these. I multiply by 3. That gives me 3x. And that 3 would cancel. Then I subtract the 2. And there we go. Same thing, multiply by 2. And then we'll add that 5. And then I could go ahead and multiply this out. And combine like terms. And this polynomial has those for roots. All right, that should be good enough to do your homework. Good luck.